Oh. Hi, everyone. Yeah, I'm so glad here to talk about microservices. And my talk will be, it's changed, the screen is not, okay. Sorry. There's something wrong? Can you help me? So, yeah, I'll start the talk anyway, so maybe he can help me figure it out. So I'm from AliExpress, and I will talk about how we do microservices in AliExpress. And I am a developer and kind of architect, and we have a team to do microservices for AliExpress. So I have some 10 experience on software development, and I also read a book about Maven, but in Chinese. So I'm Chinese. English is not my native language, and this is my first time to Europe and in Berlin, so it's awesome place. And anyone have heard about AliExpress? Wow. Used that? Still many, okay. Yeah, so AliExpress like cross-border trading platform, so you can buy many things from China, right? So here you can buy something on the phone or something small. But actually, we are quite huge, right? We are part of Alibaba group, so I bet you know Alibaba, right? So it's huge. I think we scale a lot, and we are quite big. So I think we scaled bigger. Yesterday, I talked with someone okay, we are bigger. How big? Like Amazon. Wow, really? Yeah, but it's true, right? So we are like Amazon. But for AliExpress, we are still quite big. For microservices, we have hundreds of applications. Each one can be deployed and write and deployed separately. So that's our scale, right? But it's not but that's today, right? So back in 2013, it's not that big. It's not that many applications. We have a few monolithics, 20s or 12, a dozen of monolithics. But back to then, we already have more than 100 developers. So there were some, awesome. Yeah, there were some serious issues, quite serious issues we were met. And some of them, for example, when, I joined Alibaba AliExpress 3 years ago. The first time I was there, I want to release something, I have to wait for a few hours. That's why. Why that? Because there are other people in the queue, release queue. So we have more than 100 people develop 20 applications, and you have to grab branch and merge, and before merge, you have to, you have to communicate with people. And if you are lucky, yeah, you release. But if you are unlucky, you have to wait, right? That's awesome. That's my photo, my book, okay, in China. You know what? I think it's more than 20,000 copies sold in China. We are huge, right? I think it's a good book, but you don't read it anyway. Yeah, that's some data. So we have W11 festivals. We have huge peak. So more than 230 countries, more than 6 million customers in one day, right? We place so many orders, more than 35 millions of orders. So that's a big challenge to us. Yeah. Okay, I forgot to say my agenda, but agenda basically is first I introduce you some background and AliExpress stuff and Alibaba stuff and how was it that 3 years ago and how it is now. And when we do the way to microservices, we have some principles we try to follow. And after that, there are some practices, very detailed practices. And it's mainly about Java, okay. Yeah, as I said, that we have a risk queue, right? We have a risk queue, so we have to wait. It's very, very low efficiency because of the monoliths, right? And another problem is that we have a dependency hell. What do you mean? What do I mean by dependency hell? Dependency hell means that each monolithic has so many functions and so many Java dependencies. Some new, some old, some open sourced, some our own dependencies. So it's quite easy for one application to have some dependency collisions and boom, your log is gone. You have no log, right? Boom, something wrong when you start it. And what's worse is that, okay, everything is fine, and you package and start, and after a few hours, something wrong is online because class pass collision, something like that. So that's a big issue. It's so common for one developer to spend a half day or even 1 day to debug class path collision issues. Just because the application is so huge, so many dependencies, like hundreds of dependencies, and you have no idea who's killing you, right? Okay, and the third problem we found is that most applications, like we have 20, so people are not able to start it locally in his laptop. No way to stop it because we were using like JBoss and some magic shell scripts to, copy file around, and we rely on some systems to deploy it, so some testing environment, but it's not stable enough, right? Because it's not production systems. So this kind of issues makes people feel they are when they write something and release it, they have to tackle a lot of difficulties only to write like 10 lines of code, right? So it's a problem. Okay, and that's a technical stack in 2013, 3 or 4 years ago. So some old SVN, right? People, now we hire something from universities and someone from universities, and we tell them SVN. What is SVN, right? It's like when I graduated and 10 years ago, and I learned the source version control systems, and people tell me CVS. What is CVS to me? So now everyone uses Git, so now we Git, right? So that's one key. I think it's one very, very great thing about microservices. Like we can do technical upgrade, services by services, right? If you have a huge monolithic, you don't have the courage to take a risk about upgrade it. It's so hard, and you have to stop the plan to fix something. No way, right? So we have to be online all the time. Now we do not have upgrades, like we upgrade Maven, upgrade SVN, upgrade Java to Java 8, use Stream API, and we upgrade JBoss and to use Tomcat 8, and we use some SpringBoot, right? So more than half applications here right now in AliExpress is running on SpringBoot. It's quite awesome. I'll explain you why we choose SpringBoot right later. Okay. Okay, we're gonna use Docker, right? And that's the very simple view about our architecture. So we have multiple data centers. We have some data center in China, some many data centers in China, and some data centers in America. So the left part and the right part of the picture is basically the same. Okay. What's interesting here is that we have our own binary communication protocol. HSF is like a gRPC or Swift. We have our own meta-queue for asynchronous communication called a meta-queue, which is similar to Kafka. And we have our own caching systems, similar to Redis. We call it tail. So some reason is that like 5 or even much earlier, many years ago, Alibaba already had met some issues like now all companies met. But back then, there's not so many mature tools and systems we can use. So Kafka is, I don't know which years Kafka becomes the top project in Apache. But back then, we don't have this kind of thing, so we have to build our own. It's not built by AliExpress, built by Alibaba. So Alibaba has a simple, have a dedicated department building some infrastructures, queues like RPC framework, cachings. They have like dozens of this kind of stuff. Or you can find in all the main stuff you can find in open source world. You can find some similar things in Alibaba. So that's basically the same the thing here. So we have some data layers and the caching layers and the service layers and the front end stuff, right? Front end web to the web. So within Alibaba we don't use RESTful, right? But we expose some APIs to our customers, of course, but within Alibaba, we all say the same language called HSF. So it's because the performance. Okay, it has a very, very good advantages, like performance is quite good, and it's based on Java, so all the people in Alibaba use Java, most of the people. So you can simply write some Java code and expose your APIs, right? So it's quite simple. But there are some drawbacks, right? I'll explain later. Yeah, so, and okay, I did just introduce you the stuff, right? So let's repeat something. Oh, one thing is quite important is that all our applications use the same release systems and the same monitoring systems. It's quite important. So if you don't go through the release system, basically your code cannot be go online. Okay, so you have to go through the same release systems. And also we have very, very strong like monitoring systems, like you can monitor your CPU, memory, JVM, exceptions, and some keyword stuff, and some trends, and some very very complex stuff. So we heavily rely on this to keep our stable and available. Okay. Yeah. So as we go through some like 20 or 12, this kind of monolithics into hundreds of microservices, there's some principles we want to strive, right? We know for technical things I introduced you, even we are in monolithic shape, we already have something like queues and something like caching, something like this kind of RPC frameworks. But we want something more, right? So there are 4 principles we want to strive. First one is like be able to start locally, right? So you can write something and see it. In many big companies, it's so hard, right? It's so hard. So you can get your feedback. So the feedback loop is quite important. And you have to, and the second thing is that we need to switch our mind from like reuse code to focusing on API, right? Reuse code, I think yesterday was mentioned that reuse code is some of the principles that was good, but in microservice world, most times it's not good. From our experience, it's not good actually. I'll explain why later. And the third one is we embrace OS, so we use SpringBoot and SpringCloud a lot. So when we hire more people and people can can start off fast. The final principle I want to strive that the developers takes full responsibility. So actually, we have 3 years ago or 4 years ago we have 100 developers and we have like 4 or 5 operation guys. Now we have more than 200 or I don't know more developers than that, and we don't have dedicated operations guys. So all the developers, they take responsible for their applications. So if something's wrong, even I'm in Berlin, I have to go online and get into VPN and fix something. That's a culture we have, and I think it's very core to us. All right, so that's a cool stuff from Spring Boot, right? So you can open your IDE and start it. And I think Spring Boot 1.4 can help support something like your customized banner. So I made some funny banners here. So yeah, so we can. It's changes different, right? So before we change to this way, people spend 10 minutes to start his application and get a feedback. Now within IDE, it only take like 30 seconds, right? It's a huge difference. And there are many good benefits we can get, right? Much easier to understand. So when you hire some new people, okay, today you have to be familiar with this application, be familiar with code. It could took him half day or 1 day to first get familiar with the testing environment first, right? Nowadays, go to Git, clone something, and import it to IDE and start. Oh, yeah, it's up and you can work, right? You can start working, and debug. I had many funny questions about debug, right? So people always ask me how to debug Spring Boot applications. Some JVM options. I said, do you know how to debug in IDE? Right-click, debug. Yeah, it works. But before that is unimaginable, right? But people are so used to like add some JVM options to the command line, and open the remote debug on IDE and attach it and start to go one line. It takes a lot of time, right? But now it's changed, so we like it, right? So it's a huge difference. The feedback loop is always about the feedback loop. I was thinking that the fastest feedback loop we have is like compiler, right? If you write something wrong, compiler tells you within milliseconds, right? And then you go to the unit testing, and the feedback loop like a few seconds, right? If you are TDD guys and you are pure like agile stuff, and you think, okay, a few seconds is not a TDD, and then you have to still keep it in a few hundred milliseconds. But the feedback loop is still very, very fast. And now you have to start your applications, and there's always a feedback loop, right? So it was like more than 10 minutes, and now it reduced to within 1 minute. So more feedback, and you can be more productive. Okay. Oh, okay. So the second one is API first. I think maybe how many people guys read this book? Simple book. How many guys here? Oh. So how many knows the 12 factors? Right? Yeah, much more. So this book, I think, is pivotal. They write it. So they based on 12 factors, they added 3 factors. I don't remember the other 2, but the most important factor I think is API first. It's not in the initial 12 factors applications, but now we really want to focus on the 12 factor, and also we want to focus on API first. There's some reasons, right? Because now your code is in microservice world. The code is 2 part. One part, we are Java, so we don't have from some DSL to generate some client for Python, for Java, for Ruby. We all Java. So our code is basically split into 2 parts. One part is your API, another part is your implementations, your service, right? So it's okay to write some dirty code and some garbages in your implementations, because you can easily write it. So easy to write it, right? But it's not okay to define your API randomly, because maybe it's so common in our company that within 1 year or within 2 years, we have to upgrade the API which is incompatible. And you have to beg other developers, oh buddy, I buy you a coffee, please upgrade my API to another version so I can do my upgrade, right? It's always like, I'm version A, I want to go to version B, and I have both versions running, and I start to beg. Okay, please upgrade, okay? And then you have dozens of applications upgrade to your version B, you can switch A off, right? That's why we really want to focus on the API. The API is so important. It's your domain boundary. It's your boundary context, right? From DDD's domain. And also that we have another interesting stuff is that since you are Java, you are so powerful, so you can put everything into your API. Not API, in jar, actually. You distributed your API as a jar, right? So you can put everything here. You can put even log4j properties. Imagine what that will cost, right? So if you put too many things in your jar, that will kill people. Imagine that I'm a high-level application. I depends on 20 services. Each service gives me a jar, right? That's their API. So 20 jars. But for each jar, they transitively depends on 20 another jar. Now I have 20 and 40 and 800. If some duplication removed, I still have 400 or 300. That's a lot, right? And that will cause you class path collision easily and make your application very, very, very huge. So we want to keep it simple. We have strict rules on your published API and published jar. Okay. So the third thing that we try to impress OSS, right, open source, that's because we are a distributed team. We want to be international, so we have teams in Hangzhou. Hangzhou is G20 city, and we have teams in Shenzhen, south part of China, and we have teams in Russia, Moscow. So that makes me that we want to use open source stuff. That's why, because that if you go to Alibaba internet and find some documents, it's always Chinese, always Chinese. And you can imagine that find some guy, some developer know Chinese at all, don't know Chinese at all, and he try to read some documents, and it's crazy, right? Google Translate. Yeah, that's how they do that, right? Google Translate. And even they dig into the code, try to find some comments in the code, still Chinese. So it's kind of not international, right? So we try to use more and more in the open source stuff. So of course we don't throw our Alibaba stuff away. We just use like SpringBoot and SpringCloud. They have very clean APIs, and use these APIs we plug into our services, and it works. Now when people have some questions, how to use SpringBoot, how to SpringCloud, just Google it, right? I don't care about that. Just Google it. And I think we also try to actually follow the mainstream of the industry. So we don't need to rebuild everything again and again. So 5 years ago, or even before, we always build something because it's so hard to find something in the industry we can use. But now, no, right? Or I think for engineering part, for microservice part, we are not that special. Actually, we are quite similar to other companies like Netflix or all these companies. So we don't need to rebuild everything, right? So we can reuse that. That's why you reuse SpringBoot and SpringCloud, this kind of stuff. And we choose the mainstream stuff. So this is microservice and the SpringBoot. So all the people is using it, and it's involved very fastly. Okay. Oh, the final principle still is that you are developers, you take care of everything. So people mentioned that a few days ago, right? DevOps means, who mentioned that? DevOps means that, okay, basically no ops, right? Actually, that's true in our case. We have some infrastructure. They build data centers and they control the physical machines. But at the application layer, how you scale out applications, how you reboot it, and how you deploy it, the developers takes full control. And of course, you takes some messages on your phone. Something goes wrong, you have to get up and fix it. So we have similar to SRE team, but in Chinese we have some different name. You call it 飞虎队, so fly tiger team, something like that. This team is trying to rescue you. Something goes wrong, we rescue you, right? So it's SRE basically, and this team is responsible for site reliability. But this team only responsible for emergency. So very, we have breaks about P1, priority 1, 2, 3, 4. So this team only responsible 1 and 2. 4, 3, and 4 are developers. They take their own responsibility because all the applications have its owner. The owner takes the full responsibility of these applications. Right. Okay, some detailed practices then. These are very detailed, and if you are not Java developers, maybe you feel boring. Okay, I go through one by one, right? Yeah, the first thing that we reorganized all our code base. So 4 years ago, 3 years ago, the code base is basically a few monolithics, and all the code is modules, Maven modules, all the jobs. I call it a global job because all the jobs is published into Maven repository. It's visible to all the other applications. Okay, code is really reused, but all the applications is really coupled. You see the problem? If you can imagine there are 3 or 4 people, they modify the same job, they try to reuse some logic, right? But they have to wait for others to merge. So that's why I really think that in microservice world, don't focus on code reusability. focusing on API reusability. So if your API can be reusable, that's awesome, right? I don't care how to implement it. But if you try to reuse code, okay, that's not 2017, right? Okay, then we change to this way. So we put most of the global jars into local jars, so it's only visible into one application. And so people don't reuse it, they use the API. But for each application, we have some like a published jar as an API. In this way, people can really focus on the published jar, and for local jars, I don't care about how you write it. Okay, and the published jar and the local jar and the application now is in the same Git repository. So there's no way you can deploy it into Maven repository. So there's no way for other people to use it. This is a physical boundary, right? We have built this physical boundary. This really speed up all the deployment because people don't rely on other people to, depends on other people to modify the same jar. All right. And the second thing is that we try to use Docker to make our environment consistent. Okay, so actually, because we use SpringBoot and we are based on Alibaba, so we have a few layers of Docker images. The best thing here we got is that for all our developers, they only need to write a few lines Docker file. It just depends on the same, the same images. And the images we actually control, not control, but we provide all the infrastructure like JVM, like no Tomcat. Tomcat is within SpringBoot, right? We have some monitoring agent, we have some OS and this kind of stuff. So now all the people, they don't, because it's well tested, right? It's well tested, well debugged, the images. So people don't need to think about it, and it just works. Before that, we have some magic scripts for all the applications. Each application have some magic scripts, some environment. When something goes wrong, it's not easy for Java developers to find the issue. But now, Java developers they don't care about that. It just works, and it's very stable. And because you use the latest tag for these images, and we can force upgrading. Yes, there are sometimes some security issues. We need to upgrade some stuff in the OS or some stuff on JVM, and we just deploy a new images of the SpringBoot base image, and other people just release their applications, and they will use the latest stuff. And another thing is that we found that the Docker can help us speed up deployment. Why is that? We have some environments in our company, like we have like a testing environment, and then a staging environment, and then a production environment, right? And for staging and production, we have multiple data centers. So China staging, China production, American staging, American production, right? So when you deploy something, you need to distribute your images into all data centers, and that takes time. You sometimes, usually take 5 minutes or so because your jar depends on the size of the jar, right? So if the size of the jar is like a few hundred megabytes, then maybe a few minutes. But now, since we are using Docker, and I think the image is immutable. After people they deployed their image into the staging environment, and it's start up locally, and it started successfully. Some background process can listen to this event and push your images into the production environment before you decide to go through that, right? Then, when you say, okay, I'm okay, I tested my staging environment, everything is fine, and now I decide to go to production, the image is already there. Then you just go to production, and the Docker pull is already there, and then you just start up fast. There's no need to distribute the images again, right? So it can save you time. So there's something interesting things we find Docker can help us. Okay, another practice is that SpringBoot really help us to simplify our code, right? So before using Spring Boot, to use huge XMLs, because we were using Spring 2, I saw XML everywhere. Nowadays, it's very, very easier to understand, right? So you add dependencies. HSF is our RPC framework, so it basically depends on it, and then you enable it, and you annotate one class, say, okay, this is a service exposed to other people. That's quite simple. So it's a huge difference, right? And the second thing we use Spring Boot is that it's health check. So Spring Boot, by default, they provide some health check, like discovery with Eureka, Discus, and something like that. But we implement a lot of health checks to our own services. For example, if you use HSF, there's some service discovery, right? So you have to check that if you're connected with service discovery. And if you use our MetaQ, you have to check if you are connected to the queue. If you use some cache, is the caching available, system available? So we implemented many kind of health checks. So make people feel confident when they start their application. If there's a configuration is wrong, and basically you should have failed. And only after the health check passed, you can go to bring your service online. Online means that it's open to your users. So basically, you start application and do health check. If it fails, okay, you find the reason and you start again. If it passed, okay, you bring traffic into your services. So this is very important to availability. Okay, and some metrics, right? We use job wizard metrics, and Spring Boot itself has a metrics endpoint. So these kind of metrics are quite important for developers to understand how it works, how the applications works in production. So this example, right? We use job wizard metrics can help us to gathering information about your queues, right? How you consume stuff, how you send messages, this kind of stuff. So the way we integrate Spring Boot and Alibaba stuff is that we try as much as possible to use the Spring Boot and SpringCloud API. At the same time, the implementations is Alibaba stuff, because we are very confident that the Alibaba services, they are performs very well, and they are very stable. But our API is not that good, so we try to use some open source stuff so people can learn the API very fast and they write their code very fast. Okay. Next one is that about configurations. So before we use Spring Boot, actually we have some maybe profile or something similar to that. So you have multiple data centers, multiple environment, and you need to deploy your application into this environment, but their configuration is different, right? So database connection is different, maybe caching namespace may be different, and the time zone may be different. So there are some differences in different environments. So you have to make your application, available in different environment, right? So before you use Spring Boot, actually we have one jar. Actually, that was war. It's not jar, right? It's war. Have one war and configured. Use some key value, put some key value, replace it, and to generate 3 different wars. So we have a central configuration repository, and it's configured to generate 3 different applications running in 3 different zones, right? That's the way it works. And that's not good enough, because it can, make your release process slower. And imagine if you're using Docker, you have like 3 environments, 3 Docker images. But now we have way more than 3 environments. We have like 6 or 7, even more environments, and you have so many Docker images. That's crazy, right? That's crazy. So, and we changed it to this way. So we moved the configuration, a central configuration center, into many different configurations. So for each data center, we have a configuration repository. And the application starts, when the application starts up, it loads the configurations from this configuration repository, right? It's like Jenkins. So you run Jenkins, and it can load some configurations in some XMLs, right? Similar to that. But to us, it's not easy to change that because so many configurations. We have like hundreds of configurations usually. Most of them are abused, but anyway, we do a lot of cleanup, and we switch to this way. Okay, and now our application is immutable and it's Docker friendly. We can only have one Docker image, and it can be run in many environments. Right. This is how we implement that. So SpringCloud configure, it's using Git to store the configurations. But we are not confident about the performance and the stability about GitLab. We don't use GitHub within company, right? But we have our own GitLab. But GitLab, the performance and the availability is not good enough. So we basically plug the SpringCloud API into our own configuration called Diamond. So we plug it, and it works. Because the Diamond is running in Alibaba for many years, and it's proved so stable and performing so well. So we plug it, and we store the configurations in Diamond using a convention. So for each of the application, we have a name and a group. So name column group column name dot properties is your configurations, and we store that into our Diamond. And when your application starts, it's loaded and injected into your code. And the beautiful thing here is that in your Java code, you see nothing about Git or Diamond or whatever. It's just a Spring. So it's very easy for developers to understand. Yeah. And the next thing is that we use Spring Boom to manage dependencies. Actually, Boom is something invented by Maven, right? But for many years, no one is using it. And then suddenly I found that SpringBoot is using it to manage dependencies. So imagine that you have like depends on 30 or more open source libraries, right? And you have to choose a version. Which version of Log4j, which version of SL API, which version of a Commons IO or something like that. But actually, most of the time we don't care about that. Just as long as it works, I'm okay with that, right? Only when something wrong goes, like class path collision, or you need a very cool feature of a new version of this library, you need to care about that. Then okay, SpringBoot says, okay, I give you a SpringBoot Boom, and I manage all the dependencies about SpringBoot, and you only need to care about what kind of SpringBoot applications you are using. Okay, it's SpringBoot 1.4.2 release. That's all. And most of the time, we don't care about the SpringBoot Accurator or SpringBoot Web, or I don't know. There are many small dependencies in SpringBoot. We don't care about that. We just use it, right? And the similar thing is that in AliExpress, we have many developers. They need to depend on HS, depend on Diamond, depend on many infrastructure stuff, and they don't care about the versions. They only care about give me a set, and these dependencies don't conflict with each other, and it should work. And we learned from SpringBoot and Maven, so we built something like Alibaba SpringBoot dependencies, so you can just import it. And then when you really use some starters, you don't care about the version. It simplifies the work of the developers, right? And we have something like this. Okay, our team, we are responsible for testing if these guys, they are, they can live with each other very well. Sometimes I will kick your ass, right? So, collisions. But now, as long as we tested them, and we are very confident that, okay, you only need to care about the whole BOM, and you don't need to care about the very detailed dependencies. So this simplifies the Java, the Java POM XML a lot. Yeah. Okay. And the API first. I mentioned the principle API first, right? So that's how we do it, API first. So the API basically is a jar in our case, and you distribute the jar to your users, right? But it's so easy to, for you to pollute the API. You depends on so many transitive dependencies, and this stuff, you don't feel that, but it will kill others. For example, you put some log4j XML, logback XML into your jars, and people use it, and their logs will gone, and they do go to some weird places, maybe your local laptop, some strange directories, right? And spend people half day to find it. It's this kind of things happens every day. So we have very strict rules on how you should publish your jars, right? Because it's Java, you can do everything, but you shouldn't do everything. It must be clean. That's some examples, right? No log4j, no logback, no legacy stuff, no snapshot, so many rules. So the ideal way is that your jar is only some detail, some interface, that's all, because it's interface, right? But in real case, people may have more, but you shouldn't use it, shouldn't use it. So we have strict rules, and we have a blacklist, long blacklist. Okay, how we enforce this? You can't just say, okay, you shouldn't use it, that's all, and people use it. How to control this, right? So we use a weird, it's not kind of weird, we force people to first inherit from a snapshot POM. Okay, so usually it's not advised people to use snapshot POM in their production code, right? But in this case, all your published jars should inherit from this snapshot POM, and we can control you, right? We use Maven Enforcer plugin in snapshot POM, and we have many rules. There are some examples here, but you can do way more. You can control JVM version, you can control Maven version, you can control many stuff. So here's some examples. So we have a list of banned dependencies, so you shouldn't do that. So to make sure that you don't pollute others. Yeah. That's a great way. Now all the distributed jars is much cleaner, and people are so more comfortable about using this kind of stuff, and not so many collisions issues. So it's a trick we use. Right. And naming standard, because we have hundreds of applications, so it should be very easy for people to, from the application name, to know how it does, right? Before, we don't have strict rules on how you naming your applications, but we found it's a chaos. So because all the names are basically English, right? The English name, you shouldn't use some Chinese characters in your code, right? That's weird. But they're English, and many programmers in AliExpress, they are not good at English. So they use some weird English word to describe the application name. That's weird, right? So if you send this name to some Russian guys, he say, "What the fuck is this?" Right? Basically, we have pinyin. Pinyin, use English words to describe Chinese pronunciations. So some people use it. And is this pinyin or is this English or some other weird stuff? We don't know. Anyway, we define very strict rules on naming applications. So it's 4 parts. The first part is AliExpress AE, because we have other companies within Alibaba, right? So we have to tell people it's AE, AliExpress. The second part is product. So we have a list of products. They are defined by a group of people in our. So basically, we shouldn't let people to do some business we don't want to do. So this product is a list. And if you want to add a product, you have to discuss with some board, architecture team or something like that. So it's like we have like around 20 or more products within AliExpress. So for example, we have like a inventory, right? Item, transaction, sorry. So this kind of stuff, these are a long list of, it's a big domain, right? And within the big domain, we have some small domains, right? And that's the scenario also. A final one is classify, basically about what kind of technicals you use, some front-end stuff and back-end stuff. Back-end is you have to using some like SEL, something like that, and then services, and other than some data processing stuff, like more like some streaming stuff. So that's classifier. Okay, the final thing we do is that when you migrating from the monolithic into microservices, it's practical to split something out, make it a microservice, and split something out of microservices. It's always like this, because it's much safer. You can switch back easily because the old service is still running, and you have a new microservice running, and you can bring the traffic into a new one. If everything's fine, it's great, right, from monitoring system. But if something goes wrong, you can go back. So this is the one way. And it's much easier for developers to get more and more understanding and more knowledge about how SpringBoot works, how microservices it is. So the curve is not so high. So we can see we still have some like legacy stuff running, very, very low traffic. But we just scale them down and put it there. Just runs, okay. But we have more and more microservices, have huge traffics running. So that's most of them are split from older ones. And, people have very good knowledge about this kind of domain, and they've split it out. Yeah, that's another practice that I think most of the organizations, when they migrate to microservices, they use it. Okay. All right, so that's basically what I want to talk. What Alibaba AliExpress is, our technical ecosystems, and the principles we want to drive, and also some practices we do. Now it's time for Q&A. Thank you.
So, thank you. Any questions?
Yeah.
Thanks for your thoughts. Can you share how you've organized your engineering teams and how much autonomy does the teams have to decide on technologies and also priorities inside the team?
So your question is that how to organize a team and then excuse me?
How much autonomy do your teams have?
Oh, okay, autonomy, right? Okay. Yeah, so you see that we have some like 20 products based on naming standard. So for each, I think each team, they only own 1 or 2 products. So that's the first, this team, they own 1 or 2 products. So it's their boundary context, right? And within team, each team, like the 10 or less people, within each team, they have like a small scenario, small stuff. The autonomy is that something is very strict, like communication protocol, like release system, monitoring system. These kind of things are very strict. And we use Java, so please use Java, so no other languages. That's very strict. For other places, if you want to try SpringBoot, you want to try any new technologies, it's up to you. So the infrastructure stuff is very strict. And technology part, people can choose whatever they want, but they need to take their own responsibility. For example, I want to use Kafka. Okay, you maintain it. Right? If you want to maintain it, you maintain it. Other than that, I don't care. Okay.
Yeah. First, thank you for an interesting topic.
Thank you.
And my question is, as you said, and as we see in a lot of microservices you have is written in Java. And my question is why? Because what I appreciate on microservices is to use some another languages, because sometimes it's perfect to use, and Java is sometimes are overkill. So do you have some special rules, or why are you not using another languages? Thank you.
Okay, so the question is why only use Java, right? There are I think that there are a few reasons. The most important reason is that the whole infrastructure in Alibaba is built on Java. I mean, the release part, monitoring part, and many super power tools, they are all based on Java. So if you use Java, simple, right? And if you choose to use other JVM languages, I think it's okay. Some people using Groovy and some are trying Scala, this kind of stuff. It's okay. But if you use non-JVM stuff, then it's not production ready. Because if you go to online, it's black. It's at least it's not that obvious as JVM stuff. It's like you have little tools and it's so hard for you. Another reason is that it's always about hiring. So the Chinese, in China, it's easy to hire Java people, but if you want to hire some Python people, you want to hire some Ruby people, it's very, very hard. So that's the two reasons.
Okay, thanks again for the talk. Two things. First of all, please do remember to provide feedback using either the online SCAD or the flip charts that we are going to set up. Also, in the next slot, there were originally 3 talks. So the one by Benjamin, he couldn't make it, so that one will be skipped. Thanks a lot, and see you.
Thank you.